Hello and welcome to In the Lab. This week we're going to be looking at momentum. Take it away, Mr. Walker.
Okay, we have got two different balls of different sizes. The first one, as you've noticed, is a basketball, and when I drop it, it does that. A tennis ball, when I drop it, it does that. So you've noticed different heights of bounce. But the question is going to be for you, what if I put the tennis ball on top of the basketball and I drop them at exactly the same time?
That's an interesting one. I mean, we know a bit about momentum and how that can pass from one object to another. So there's going to be some form of energy transfer, and I feel like there's going to be a slight difference in the height there.
Well, we'll find out. We'll pause the video now, have a little think, and we'll show you in a moment.
Okay, welcome back. You should have had time to note down your predictions, and now we're going to see what actually would happen.
Okay, here we go. I have to make sure I drop them at exactly the same time so that they are touching when they hit the floor. Here we go. Now, is that what you expected to happen? That was a little bit different to the heights of the initial heights of the balls. What happened was, this has a huge amount of energy. When it hit the floor, it transferred the energy into the tennis ball. So even though the tennis ball was going to go up to a tiny height on its own, it had a lot of energy, conservation of momentum we call it. The momentum went from here to here, and this shot up in the air.
Wow, that's super interesting to watch, and I think something that some people might have missed, and it'd be worth a second try, is to actually watch what happens to the basketball. It's slightly different to normal.
Yeah, it's a good point. Everybody watches the tennis ball. Don't watch that, watch this. I watched the tennis ball again, but I hope you watched the basketball and noticed that normally the basketball goes up to quite a high height. With the tennis ball, all the momentum goes into the tennis ball, so this only goes up a tiny amount of height. Well, there is something I'd like to try. We did that with a tennis ball. I've also got a ping pong ball. Now, what do we think is going to happen on that one? We won't pause it this time. I think we'll just give it a go. So we've got a much smaller ball on top of the basketball. Here we go. Well, that was a little bit disappointing, I have to say. Any thoughts as to why that might have happened?
So I feel like there was a slight problem with the two objects meeting each other at the bottom. The momentum wasn't passed on from the basketball because the ping pong ball seemed to fall slightly slower than the basketball there.
I think you're right. Because of the air resistance of the ping pong ball, it's much lighter. I don't think it falls just like these would fall together. I think the ping pong ball actually falls with a slight gap. So there isn't conservation of momentum. As you said, the momentum from here doesn't transfer into the ping pong ball, but it does with the tennis ball. Well, I suppose you could have a go with stuff at home, as long as you get permission and you don't do it inside, because you'll smash stuff. Enjoy.
See you later.